For this video, I picked out an internal resistance and EMF calculation type question. There's also a bit of a wordy section here as well that we'll have a look at. So just to start with, it tells you the EMF on each of these lamps is 1.5 volts. So let's start by replacing, or sort of labeling that, not replacing, sorry. Okay. It says the resistance of each resistor is 4 ohms. So there's 3 resistors here. And it's asked then for the total resistance of the circuit. To find the total resistance, you want to find the total resistance going through all 3 of these resistors. You first use the idea that these two are in parallel, and we know that in parallel, 1 over the total resistance is 1 over one of the resistors that are in parallel, plus 1 over the other resistor that's in parallel, so on and so forth for however many resistors there are. In this case, because there's only 2 resistors, we can say that 1 over the total resistance of the parallel combination is 1 over this first resistor of 4, plus 1 over the second resistor of 4 as well. That adds up to 2 over 4. If 1 over the total resistance is 2 over 4, you can then flip both sides of the fraction, and you can say that the total resistance of the parallel combination is 4 over 2, which is just equal to 2 ohms. But that's not your final answer, because the total resistance of the circuit, you also have to take into account this 4 ohms. We then use the idea that, well, this junction here, all of it is in series with this component here. So in series, we add the total resistance together. So now that we've got the resistance of this whole junction, which is 2 ohms, we now add it onto this resistance here of 4 ohms. And that adds up to 6 ohms. So just a quick reminder, this resistor here is in series with this whole junction. So we started by finding the resistance of this whole junction and then added it to that resistor there. It then asks you to find the total EMF of the combinations of all the cells. A very common mistake students make is they add up 1.5 4 times, but the thing is, what we know about voltages in parallel is that it's the same. So the total voltage that goes into this junction is 1.5 volts, and it doesn't split up because it's in parallel, so it just stays the same across both components. If there's 1.5 volts in this whole junction here, another 1.5 volts going into C, and another 1.5 volts going into D, we add up 1.5 3 times. So we do 1.5 multiplied by 3, and that's equal to 4.5 volts. That's the total combination of the EMF in this case. Moving on now, it's then asked for the current flowing through cell A. Well, let's think about it. Do we know the resistance across cell A? We don't really. But I just realized a quick little thing that can speed this question up. What we can do is find the current through the whole circuit and then split it up across components A and B. So let's do that. The total voltage, so we know current is voltage divided by resistance. We've also found the total voltage flowing through the circuit, which is the total EMF flowing through the circuit of 4.5. We divide that by the total resistance, which we have also calculated as 6. So that's 0.75 amps. That means that 0.75 amps flows through C because it's in series with the whole circuit. It flows through D, but it doesn't flow through both A and B, because what do we know about current in parallel? We know that in parallel, current splits up. By the way, how I used to remember all of this, now I pretty much memorized it, but I'm just going to show you guys how I remembered it. I used to remember that in series, current stays the same, and then everywhere else is the opposite. So voltage in series is split up, current in parallel is split up, and voltage is the same in parallel. So I used to just remember this part of the diagram and just fill in the rest of the diagram as necessary. Okay, so we know that the current of 0.75 amps, it splits up across these 2 cells here. Because we know these 2 cells have the same resistance, they're all identical. That means that the current of 0.75 that splits up across these 2 is split up evenly. So the amount that reaches cell A is just half of 0.75. So that's equal to 0.375 amps. And that's your answer to this part of the question. Great. Moving on to part 4, it's asked you to find the charge passing through the cell A in 5 minutes with an appropriate unit as well. So that's the 2-mark question. You guys might have realized charge is equal to current multiplied by time. Current flowing through cell A, well, we've calculated that it's 0.375. Sorry, that kind of looks like 0.395. I'm just going to write out one more time here. 0.375 amps. So yeah, you multiply that current that flows through cell A, multiply by the time taken, or the time for which it flows through cell A. So 5 minutes, you convert that into seconds. We know 1 minute is 60 seconds. So you take 5 and you multiply by 60. Let's multiply all these variables together. So we have 0.375 multiplied by 5 multiplied by 60. And that's equal to 112.5. Now the unit for charge is coulombs, so that's 112.5 coulombs. It then tells you each of the cells can provide the same amount of electrical energy before going flat, and then explains which two cells in this circuit, so A and B or C and D, would you expect to go flat first. So when does a cell go flat? It's when too much current or too much power flows through it. In this case, let's deal with current. So we've already found that 0.375 amps flows through both A and B, whereas 0.75 amps, the current through the whole circuit, flows through C and D. So it's more likely that C and D would go flat first because it has more current flowing through it, and that makes it more likely for it to go flat first. So I'm just going to quickly type that out. We say cell C and D would go flat first since more current, or if you want to be specific, you can say double the current flows through both of them in comparison to cells A and B. I don't know why it's writing out so small. I'm just going to quickly enlarge it. Yeah, there you go. And that's everything for this question. If you guys do have any questions with it, just let me know in the comments. Otherwise, yeah, be sure to like the video if it helped, and subscribe. I'll post more content like this very soon. Be on the lookout.